All right, last section here. This one's a little bit different. Still kind of involves some circles, but not all circles. So a locus, not a locust, is a set of all points which meet a stated rule. And we can describe these locuses in a plane, or we can describe them in space. So we're going to start off by here describing the locuses in a plane. So in a plane is like two-dimensional. If you're in space, we're kind of thinking three-dimensional. So the point's 1 inch from a given point C. So if you had a point, so I'm in a plane here, so I'm just two-dimensional. So if we have a point here and we think about all the points that are going to be 1 inch from point C, what am I going to end up with? I'm going to end up with a circle with a radius of 1 and a center at C. The next one, again, we're still in the plane. So next one says the point's 1 inch from a given segment. So here's my segment, AB, and I'm thinking about the points that are going to be 1 inch all the way around. So at every point, every place, they're 1 inch from that segment there. So I end up with an oval. Oh, and we don't really talk about ovals, that where this distance. We don't really talk about ovals having radius or radii or centers or anything like that. So I'm just going to draw the picture and say it's an oval. All right, the next one says the points equidistant from segment AB's endpoints. So all the points, so what are all the points that would be equidistant? So everything to be equidistant, it would have to be on that perpendicular bisector. So anything on the perpendicular bisector of segment AB. And then the next one says the points equidistant from the sides and the interior of an angle. So if I had an angle here, and if I wanted the points that were equidistant from the side, but it was on the inside of the angle, that would have to be anything on the angle bisector. So again, I'm just trying to describe the set of points which follow this rule here. So locus in space, again, now we're talking about 3D here. So it says, what's the locus of points in space that are 3 units from point H? So this is kind of like the one up here. So I have this point H here, and then I have all those points that are 3 units from that. But remember, I'm in space, so I'm 3D, so I've got all the points going all the way around it. So I end up actually with a sphere with a radius of 3. So I don't know why I wrote it like that. Radius equals 3. And center at H. And then the last one, so it still says I'm in space, but it does say in a plane. So what is the locus of points that are equidistant from 2 parallel lines? But I'm still, so here's my 2 parallel lines. So I have these 2 parallel lines in a plane, but my answer is still going to be a 3-dimensional answer. So it says, what's the locus of points that are equidistant from 2 parallel lines? So if I was only in a plane, if I was only 2-dimensional, it would just be that one line. But it's actually going to have to end up being a plane that's in the middle of those 2 parallel lines, because that plane right there, so again, those points would all be equidistant. All right, and that is it for 12.6.